Hey guys, welcome to this video, and we're just going to continue with our log laws. Last time we looked at just a basic introduction to logarithms, and so we're just going to continue that series and looking at this whole range of log laws, looking on the right hand side. I want you to really, I guess, make connections with your index laws. Okay, so we know, let's see, looking at the left here, top in the square, we've got a to the power of x equals y. Okay, that's your exponential equation. And if you turn into log form, we've got log base of a, y is equal to x. So the result is you find what the exponent is. Now, we know that if you multiply like bases, okay, what do you do with the powers? You add them, okay? So that's why you add the logs. When you add the logs, then you multiply those two results, okay? The opposite as well, when you divide like terms, what do you do to the powers? You subtract. So when you subtract the logs, you're going to divide those results. So that's just putting everything in reverse and in context. So just making those connections with the index laws that you're familiar with. What do you do when you raise a power, raise indices to a power? You multiply those powers, right? So then what you do here, you multiply when it is raised. So the n can actually go to the front, multiplying it by everything. And you know, the moment you get used to this, you'll start to get the hang of it and make those connections with your index laws. We all know that anything to the power of 0 is 1. So that's another thing, just to make connections with the index law, with these logs, and knowing how you do it in reverse. And then at the same time, the only solution for any term to equal itself in index form is raised to the power of 1. Okay, so anything to the power of 1 is just going to be itself. With negative indices, okay, or fractional indices, anything at the bottom, you'll see that it'll be a power. This would be x to the power of negative 1. And if we tie it on with this index law, if this was a negative 1, you could multiply it and put the negative 1 in the front, which is what we've done here. And then next one, if we're looking at this index, this log law, I would say it is a combination of this one here and this one here. No, actually, sorry. It's just a combination of this one. So just in sense, let's forget about this part here, the x. Anything log base a is equal to 1. So if this whole thing is 1 raised to a power, so it's just going to equal x. Then with the last one, a to the power of x in log form is going to be log a y is equal to x. So just thinking about that conversion into log form, you're going to do the same thing to both sides. Okay, so a to the power of x is going to turn into log 10 of a. B is going to be log 10 of b. So, and then to work out what x is, you're going to divide the b by the a to get x on its own. Okay, so just looking at the bottom here, we've got just an example of 2 to the power of x equals 7. So this is 2 is your a and 7 is your b. So you've converted both sides into log form. So x log 10 2 is equal to log 10 7. To get x on its own, you're going to divide log base 10 7 by log base 10 2. And that is how you get x. So that's a really quick run through that list, but fear not, I've got a couple of examples to go through and hopefully this will help clarify how to use them and just get you more familiar and used to these log laws. Now, obviously, being a video, you can always pause, revert back to certain segments and replay it if you wish, and just break it down and try to make sense for it yourself. So here we go. First one here. I might just use a different color. We got log base 1020 plus log base 10.5. And what do you do to those two terms? You're going to multiply. So we've got log base 10 and 20 times 5 gives you 100. I'm going to then revert it back to index form. You know, obviously you can throw all of this in a calculator and then get the answer, but that's not really going to display and prove what you do know if you had to do it manually without the calculator. So what is, in terms of base 10, going to give you 100? That is 10 squared. So the answer is going to be 2. Okay. Next one is going to be, so we're dividing this time because we're subtracting one log from the other. And so what we'll have is log base 4, 20 divided by 4, that is equal to 5. 20 divided by 5 is going to be 4. There we go. And so what we'll end up having is, I might change that to a 4. So then 4 to the power of what is going to equal 4? That is simply 1. So 1 is going to be your answer. The next one, we've got 3 terms, and we're just going to work left to right because I guess it's just addition and subtraction involved. So let's do that first. So we've got 35 times 15 is going to give you 525. So we'll have log base 5 is equal to 525, and then we're going to subtract log base 5, 21. What we do to these two numbers is we divide, okay? So 525 divided by 21 is going to be 25. So we end up having log base 5, 25. And then if we go back to the start of what we did in the previous lesson, 5 to the power of what gives you 25, and we know that it is 2. So 2 is your answer. All right, so middle column. We have 2 times log 6 raised to log base 6, 3. And if we look at this index law, we can see that we can move that coefficient to the top as a power. So that's what I'm going to do here. So log 6, 3 squared plus log 6, 4. Now, what do we do with these numbers? When we add them, we're going to multiply. Okay, so then we know that 3 squared is 9, so 9 times 4 is going to be log base 6, 36. And so the question is now 6 to the power of what is 36? And we know that answer is going to be 2. So 2 is going to be your answer. Okay, next one. Again, same thing. We're just going to work from left to right. And in this case, I'm going to multiply the 4 and the x. So we got log base 2, 4x minus log base 2, 8 is equal to 3. And when we subtract logs, we're going to divide. Keep in mind that the bases will need to be the same. So what we can say is that log base 2 is 4x over 8 is equal to 3. Alternative, and then when we simplify this fraction, we're going to get x over 2. Now when we get to this point, let's throw everything back and revert into index form. What we'll end up having is asking yourself, well, 2 to the power base 2 to the power of 3 is equal to x over 2. Okay, so we're no longer looking for what the power is like the previous questions. But in this case here, we already know it. It's been given to us that it's 3. We actually just need to work out what x is. Okay, so we know that 2 to the power of 3 is 8. So what is the value of x needing to be when you divide it by 2 gives you 8? That answer is going to be 16. So that is the value for x. Okay, moving along with our index laws and our log laws. So just flipping back and forth, making sure you get familiar with it. We're going to go from left to right, and we got log base 4.5. And because it's a fraction, we can convert that into index form. So that means we got log base 4, 2 to the power of minus 1. And just working off this index law here, we're going to move the minus 1 to the front. So we got minus 1 times log base 4, 2. Okay. Now, this is going to be the same as minus 1 times log 4, 2. And if we think about this term here, firstly, so 4 to the power of what gives you 2? So if I was just to write here, 4 to the power of what is equal to 2, then this answer should be a half, because the square root of 4 is equal to 2. Okay, so then what we could say is that, well, if log base 4, 2 is equal to a half, and we're multiplying it by minus 1, which is our coefficient, then our answer is negative half. All right, so you're finding that with logs, with index laws, algebra, it is all just shuffling pieces like a puzzle and seeing what fits, looking at your pieces. Take your time, really analyze your parts without, rushing is not really going to help you. Okay, next one. I'm going to do exactly the same thing. We've got minus 2 up the front, so I'm going to move it to the front here. Log 6, 6. And then if we look at our log laws, anything, a term, the base and that value is just going to equal 1. Okay, so what we'll end up having here, we have minus 2 times 1, because log base 6, 6 is just 1. The coefficient is minus 2. Minus 2 times 1 is equal to minus 2. Moving along to the next one. What we'll end up doing, I just want to convert this into index form. So we got minus 1. So we've got that. And then this minus 1, again, can be multiplied and brought to the front. So what we end up having is a minus 6 log log base AA. Again, like just the previous one, this section will turn into just a 1, and we'll multiply it by minus 6. So our answer is just minus 6. All right, moving along to the fourth example, we're going to again convert this surd into index form, and what you'll end up having, just focusing on these brackets here, that is the same as 1 over a to the power of a third. Now I don't want it in fraction form, so I'm going to bring it to the top and do the reciprocal. When we do the reciprocal, we're going to flip the polarity, so the index becomes, or your power becomes negative. Okay, so I'm going to rewrite all of that. So we have log base a to the power of a negative third. Okay, Bringing this raised power to the front, I end up having negative third times log a base AA. Log base AA is going to be 1. Multiply it by a negative third, your answer is going to be negative third. Okay, so you can use your calculators and then see if you get the right answer. And it's a good way of checking, but obviously I'd be expecting you to show your working out just to demonstrate your understanding. Finally, last one at the bottom, we got a nice long one here, and hopefully we put everything together. Log base 5 4 minus log base 5x, you're going to be dividing. Good. So we got log base 5 4 over x plus log base 5 3. And when you add the logs, provided the bases are the same, we're going to multiply. So 4 times 3 is going to give you 12. So log base 5, 12 over x is equal to log base 5, 6. So make sure that you rewrite everything. Now, just a really quick side step. If we had something like 3 to the power of x is equal to 27, we can convert 27 to 3 to the power of x, or 3 cubed, okay? Because 3 cubed is 27. Now, because the bases are the same, we can ignore them and just say that these two components are equal to each other. Same thing with this stage, because the bases are the same and we're working on an equation, we could ignore this and say that 12 to the power 12 over x is equal to 6. This part here should equal this part. Let me get rid of that triangle. So this part here should equal this part here. All right, so now we're just working out, well, 12 divided by what gives you 6? X is going to equal 2. Okay, so hopefully that helps you get just a well-rounded overview of each of the log laws, and it will take some time, so I just encourage you to practice. Got any questions, let me know. Otherwise, I'll see you in the next video.